So our last lesson before the test, solving rational equations. So the objective today is to determine the solutions of rational equations. So whenever we're finding solutions, that means we're actually solving for x. We're solving for a variable. Okay, so we're actually going to find out what x equals. So let's look at the definition of a rational equation. A rational equation is an equation with at least one rational expression. So the best way to solve any equation involving fractions or rational expressions is to multiply the entire equation by the least common denominator. So the least common denominator is the same thing as the least common multiple. And notice we're multiplying the entire equation by the least common denominator. So let's look at the first example, and then you'll understand if you forgot what the least common denominator is. I think it'll make sense. So it says solve. So you notice how these are the three denominators here. We have a 3, we have a 2, and we have a 15. We have to figure out what the LCD is of 3, 2, and 15. So first of all, when looking for the LCD, find the multiples of the greatest number first. That would just be my tip. You don't have to, but you see how there's a 3, a 2, and a 15? Let's look at the 15. Because it's easier to say, instead of like 2, 4, 6, 8, 10, 12, we're going to be going on forever if we start with the 2. But if we start with the 15, we can say, okay, what are the multiples of 15? Well, 1 times 15 is 15. 3 goes into 15, right? 3. So we're looking for a number that all 3 of these numbers go into. 3 goes into 15, but not 2. So let's keep looking. 15 times 1 is 15. 15 times 2 is 30. Well, 3 times 10 is 30, and 2 times 15 is 30. So both 3, 2, and 15 go into 30, right? 3 times 10, 2 times 15, and 15 times 2. All of these go into the number 30. So notice it says the best way to solve any equation involving fractions, which we have fractions or rational expressions, is to multiply the entire equation by the least common denominator. We found out the least common denominator is 30. They all have 30 in common, right? We can multiply everything. So it says multiply the entire equation by this. So we're going to multiply everything by 30. So notice what I just did. I'm multiplying this by 30, I'm multiplying this by 30, and I'm multiplying this last fraction by 30. So if I look at this first piece and I multiply it by 30, look at this 3. If I think about this, whatever on the bottom of a denominator is technically dividing, right? So let's think about it like this. What's 30 divided by 3? That's 10. So I have a 10 left over, and I'm going to multiply it to the top piece of my fraction. See how that x plus 1 is here, right? And I just multiplied 10 by it. Why did I multiply 10 by it? Because 30 divided by this 3 is 10's left over, so I'm going to put a 10 here. Let's do the same thing. 30 here. Well, 30 divided by 2 is 15. So I'm going to do 15 times my top, which is just 15 times 1. Equals, and then here, I have 30 divided by 15. So 30 divided by 15 is 2, and 2 times 2 is 4. So now I'm going to distribute 10x plus 10. So all I'm doing is 10 times x and 10 times 1, plus 15. 15 times 1 is 15, equals 2 times 2 is 4. Now I'm going to collect like terms. 10 plus 15 is 25. So I've just brought the 10x down. Plus 25 equals 4. And then I subtract 25 from both sides to collect like terms. 10x equals negative 21 and divide by 10. So my x equals negative 21 over 10. Yes, it's a fraction. Yes, it's ugly. And we don't like fractions like that, but that's your answer. So again, you see how there's an equal sign now? That means we're actually solving for this variable. We have to find it. The easiest way to find it is to multiply each of these pieces by something called the LCD, which is just the least common denominator. And then we take that LCD and we divide each time by the denominator of each fraction. Whatever's left over, like 30 divided by 3 is 10, we multiply that 10 or that piece left over to the top. And then this is easy, right? We like these problems more than this. So we want to get it to this. Okay, let's go on to the next one. Number 2. if we have this, now notice here we have x plus 4 and x. We do not have numbers. So we have to find the LCD. I'm going to put that 9 over 1 because we can make it a fraction. Our LCD is going to be x times x plus 4. When we have variables and we have an expression like x plus 4 and then x, we just take, it's kind of easy because you just think, okay, LCD of 1x and x plus 4 is just x times x plus 4. You just take both of those pieces and you just say, okay, I'm going to take one of this fraction, one of this fraction, and that's my LCD. So with numbers, you have to find the smallest multiple. In this case, if there's an x plus 4 here and an x term here, we're just going to say both of those are the LCD. We take one of each. Okay, so we're going to multiply. Remember on our last slide, it said we need to multiply everything here by the LCD. So we're going to multiply everything by our LCD here. So now when I multiply x times x plus 4, if I multiply it to here, remember I'm taking this and I'm dividing it by this bottom. Well, which ones do they have in common? They have x plus 4 and x plus 4 in common. So actually, for my first fraction here, this x plus 4 is going to cancel, and what are we going to have left? We just have this x left, right? So I'm going to write 6 because my 6 came from here. My x plus 4 is canceled out, and I have an x left, so I'm going to bring that x down here, 6x, 6 times x, plus, now, we're looking at this fraction. What cancels out on that fraction? Well, I have, use a different color. I have an x here and an x here. So that cancels out. What am I left with? I'm left with this x plus 4, and I'm going to multiply that. So now I'm going to bring down that 2, because that 2 came from here. The x's cancel, and I'm going to multiply that 2 by x plus 4. And then the 9, notice the 1 doesn't cancel with any of these, so I'm going to give the 9 the x and the x plus 4. Okay, so 6x plus, I'm going to distribute that 2x plus 8 equals, I'm going to distribute, see how 9 times x times this? I'm going to say 9x, and I'm going to distribute it to each piece. So 9x times x is 9x squared, and 9x times 4 is 36x. Okay, you guys, if this is confusing right now, please don't worry. We have plenty of examples. This is going to be kind of a long video, but just watch it. If you're confused, just watch right now, because I'm doing a lot of examples for your benefit so that you can see how this works and you can have practice with a lot of them, okay? So just stick with me. Math takes a few days to sink in. It always does, okay? All right, so now we're going to combine like terms. On the left side, that's 8x plus 8, and I'm going to keep the right side the same. Do you see how we have a 9x squared, right? We have 36x, we have an 8, and we have an 8x. We need to combine all of these. We need to move all of these over and set it equal to 0. Why? Because whenever we're solving and we have an x squared term, we have an x term, and we have a no x term, which you'll see what I mean, we have to set it equal to 0. So I think you'll start understanding. Hang on. So subtract 8 from each side. I'm just going to set it equal to 0. So that cancels out. I'm left with 8x equals this whole thing. 9x squared plus 36x minus 8. Then I'm going to subtract 8x. That cancels. I have 0 on the left-hand side. 9x squared stays the same. 36x minus 8x is 28x minus 8. Okay, why did we do this? Because when we have something in, what is this called? This is a quadratic equation, isn't it? Because it has an x squared. When we have an x squared, an x, and no x, do you remember what we do? There's two different things we can do. We can either use the x, right, this thing, a times c and b, right? And if this might work, I'm not sure, I didn't do it for this one. But if this doesn't work, the only way to solve for x here is to either do the magic x, right, and then we have to do the box, okay, or the quadratic formula. Those are the only two ways we can solve something with an x squared term, an x term, and no x. This is called a quadratic equation. The only way we can solve a quadratic when we have it in ax squared plus bx plus c. This is called standard form, right? When we have it in standard form, we have to use a quadratic to solve for our x, okay, because it has an x squared term. We could also, like I said, we could also use or, I'll write this out, or the x, which a times c and then b, right? And then we'd have to use the box after that because remember that a is greater than 1. Now, I know this is a lot of stuff. It's all coming together right now, all the stuff we learned. So we're going to have plenty of time to practice. Just kind of soak this up, I guess, okay? But I'm not going to solve for I'm not going to do the quadratic formula, honestly, just because I don't have room. But if you wanted to try this, go ahead, because we're not actually finished. Like, in order to finish this problem, we'd need to say x equals and some kind of number, okay? So we would have to use a quadratic formula, but I ran out of room, so we'll get practice with it later. Oh, geez. I wrote the quadratic formula right there. Okay. That's fine. I'll rewrite it for you guys. Okay, so let's do another one. Solve. All right. So here we have to find the LCD. We're going to put that 4 over 1 because we always want to make all these fractions, okay? The LCD, remember, just like our last problem, it's the denominators. It's always we're always looking at all 3 of the denominators. And if we have an x plus 9 and an x minus 8 over here, both of those are going to be our LCD. If we have actual numbers, like in the very first example where we had, 15, 2, and 3, then we have to find the factor or the multiples of the greatest number. But in this case, it's kind of easier because you're like, okay, well, that's x plus 9, x minus 8, done. That's my LCD. Now I'm going to multiply that to every single piece of this. So I have x plus 9 times x minus 8. Now again, what does this, do you see how this x plus 9 is going to cancel out with this x plus 9? So I'm going to bring the 32 down, and I'm going to multiply it by whatever's left over, which is the x minus 8, because these x plus 9s cancel out. I'm going to bring down the negative 2, and you see how these x minus 8s cancel out? So I'm going to multiply that by x plus 9 equals, and then this 1 on the bottom doesn't cancel out with any of them, so it's going to be 4 times x plus 9 times x minus 8. Okay, now distribute. So 32x, 32 times negative 8 is negative 256. Negative 2 times x is negative 2x. Negative 2 times 9 is negative 18 equals, so I'm just going to distribute this piece first because we have to do 2 different steps here. So 4x plus 36, wrap that in parentheses, and I'm going to just bring down the x minus 8. So all I did was distribute that 4 to the x plus 9 and then bring down the x minus 8. Could you have distributed the 4, like let's say you put the x minus 8 first and the x plus 9 after? Could you have distributed it to this piece instead? Yes. It doesn't matter which way you multiply this. You can multiply it any way you want. Okay, now we're going to collect like terms. 32x minus 2x is 30x. Negative 256 minus 18 is negative 274. And then we're going to FOIL. So 4x times x is 4x squared. 4x times negative 8 is negative 32x. 36 times x is 36x, there you go. 36 times negative 8, negative 288. So let's collect like terms on the right-hand side. So that's going to be 4x squared plus 4x minus 288. Okay, again, just like the last example, remember I said we have to set it equal to 0 when we have an x squared term, an x term, and then no x, right? And we have to add this over here, subtract the 30x over there, so we can make it equal 0. So that cancels. We have negative 274. We bring that down. We bring the 4x squared down. 4x minus 30x is negative 26x. We bring this down. Now we're going to add 274 to both sides. 0 is left on the left-hand side. If we combine these two, negative 288 plus 274 is negative 14. Now we have ax squared plus bx plus c. This is called standard form. Now we have to use the quadratic formula or the x to solve. Again and again, I ran out of room. So this is how we do it. This is the quadratic formula right here. This is the quadratic formula. This is A, B, and C. So try solving this. I want you to plug in this for A, this for B, and this for C. Plug it into this guy. See if you get your answer as 7 and -1/2. See what you get here. Raise your hand if you're confused and you want me to help you, okay? But this is really good practice because we're bringing this back. This guy never goes away, so try it. Okay. Okay, number 3. Now, notice this guy down here, x squared minus 9. This we can factor. So let's see how there's a square term here, and then this is the c term. Remember how there's no b term inside? So there's no b term, so we're going to use this x. Our a times c is just -9, and remember our b is 0. We worked on this last time. So our 2, what multiplies to -9 and adds to 0? -3 times 3, right? So now we can just jump into x minus 3 and x plus 3 because the a term up here is 1. Okay, there's a 1 in front of that x squared, so we can just jump straight into here. I'm going to replace this with this. Okay, you notice something here? We have an x minus 3, an x plus 3, and an x minus 3, x plus 3. You take one of everything they have in common. So there's an x minus 3, I'm going to write x minus 3 here. There's an x plus 3, I'm going to write x plus 3 here. This has an x minus 3 and an x plus 3. There's nothing new, so I don't need to add anything to the LCD. So it's just going to be x minus 3 times x plus 3. You don't need to write it twice. Okay? All right, now we're going to multiply that whole thing by the LCD. So what do I cancel out here? Well, this has an x minus 3, cancel it out. I'm going to bring this x term down and multiply it by x plus 3. Now this one I cancel out the x plus 3, so I have an x minus 3 left, and I'm going to say plus x times x minus 3 equals, and then here I cancel both of them. X minus 3's cancel, x plus 3's cancel, so I have just a 2 left on the right hand side. Okay? So distribute that x to each piece. X times x is x squared. X times 3 is 3x. Here x times x again is x squared. X times -3 is -3x equals 2. We're going to combine like terms. X squared plus x squared is 2x squared. And this cancels. Positive 3x minus 3x just cancels at 0. And then equals 2. So I just brought this 2 down, equals 2. I'm going to divide each side by 2, and I have x squared equals 1. Now, here, when I have an x squared, do you see how I do not have a b term again? You see how it's just x squared equals 1? How do I get rid of that x squared? How do I get rid of that squared? What's the opposite? Like here, this was multiplying 2 times x squared, so I do the opposite, which is divide. What's the opposite of a square? Square root. So the square root of x squared makes it x, and the square root of 1 is 1. But whenever I take the square root of something, I have to put it plus and minus, right? So the square root of 1 is plus it or minus 1. Why is that? Because if I square to get back to that number, -1 squared is 1 and 1 squared is 1. That's why x is plus or minus 1. So whenever we take the square root of something, we get a positive and a negative. Okay? All right. Now, I didn't do this in the last problem, so forgive me for that. But restrictions, we have to mention the restrictions whenever we have a variable on the denominator. So do you see how there's an x minus 3 and an x plus 3, x minus 3, x plus 3? Okay, so see how these denominators here? We need to say, okay, a restriction just tells you what x cannot equal. So if I plugged in what number would I plug into this to make it a 0? If I plugged in a -3 for x, Negative 3 plus 3 is 0. We cannot have a 0 on the denominator, so x cannot equal negative 3. Look over here. What would I plug in for x here to make it 0? Well, 3. 3 minus 3 is 0. So, and I can't have a denominator of 0. So our restrictions are negative 3 and 3. So to find the restrictions, you can either just think about it logically, like, okay, well, negative 3 plus 3 is going to equal 0, so x can't equal negative 3. And 3 minus 3 is going to equal 0, so x also can't equal 3. You can think about it that way, or you can set it equal to 0. So if you set x minus 3 equal to 0 and x plus 3 equal to 0, then you'll find out what the restrictions are. You don't have to do it to this piece because x minus 3, x plus 3 is the same as this side. Okay, so that's why I'm not touching this. If this was a different, like if this was x plus 5, you'd have to set this equal to 0 as well.